Welcome to today's podcast. In today's session, we have with us an expert from a field related to batteries. Ramesh Natarajan, a veteran with over 42 years of hands-on battery industry experience, will be asking our esteemed guest a host of technical questions. Enjoy the session.
Hello everybody, I'm with Mr. Achim Lulsdorf, and he's an expert in batteries and battery chemicals, and he's been over 30 years in the battery industry, and he started his career with Excite Germany and was with Hammond, and later on was also the R&D president of Excite India. And I'm going to ask him a lot of questions related to battery, especially with the additives, especially with respect to the additives, the paste chemicals. And good morning, Mr. Achim. Can you please, tell the audience a bit more about yourself before we start the session?
Absolutely. Good morning, Mr. Ramesh, and it's wonderful to meet you, and it's wonderful to address the audience. So yes, I think number one, I'm really passionate about lead acid batteries. This has been my career for the last 30 years. I'm a physicist by trade. I was born and raised in Germany and started as a laboratory manager right out of college for Excite Germany. And then I had the opportunity to really do about everything. I learned about processes. I was the head of design of BMW batteries when I was in Portugal for Excite Portugal.
Oh, okay.
I went then to America 23 years ago. I came to Douglas Battery, who was the sole supplier of the BMW plant, so I was the head of the design team. Then later, it took me through 5 different countries, actually, the career, so I learned different applications, and it was really fun ride. Most importantly, the ones I have enjoyed the most was really being the CTO of Hammond. Being in charge of their material research and expander program. And my heart is really, there's always a piece of my heart in India. I had the opportunity to serve as president R&D for Excite Industries for 3 years, which was a great experience.
You're based in Calcutta or
Hosur? Based in Calcutta, where they have the main R&D center.
Yes.
And I learned something really new. Applications in India are very different than in most of the world.
Probably batteries are abused more here.
More abused, you have power outages, you have a lot of things to take into account. So that was a great experience for me. And then my last corporate engagement was for the Metair Group, a global director technical for the whole Metair Group, based in South Africa. And then, I was stationed in Turkey, and I took care of all the Metair companies technically. And ever since then, I have been a consultant, and I have been enjoying myself still in the battery industry.
Achha, now this, you are now with Associated, and that's why we're talking about the expanders.
Yeah.
Right? So I just wanted to start with some basics, A battery plate is made using a lot of chemicals, which are also referred to as additives. And these are added during the paste mixing phase. What exactly are these chemicals added during the paste mix, and why are they required?
That's a good question, Ramesh. So I always distinguish between 2 categories, I would say. There is essential additives.
Yes.
That, almost every battery has that, and that's almost independent of the application. And then there is performance enhancing additives.
Yes.
That are more like, tailored to certain applications and conditions. I'll give you an example for essential additives. For example, the fibers, right? They're added to the negative and positive active material, and the expander materials that are exclusively added to the negative active material. But they're basically in every battery type. They're available. So the fiber, maybe if you want to, I can get a little bit into the function of those additives. Briefly.
Yeah,
fiber, so every battery has that, and it's in both active materials. If you look at it under scanning electron microscope, it almost looks like a thread, that's woven through the active material. So it literally holds
it binds the active
material together. The expander the whole function there is a bit more complex. If you put it in simple words, the expander works to maintain the large surface of specific surface of the negative active material, of the crystals, right? Of the needle type crystals. And during discharge, the danger is that the lead sulfate basically builds a blanket, a passivating layer on the negative active material, and therefore it reduces the specific surface. So basically, that would have a negative impact on every type of high rate discharge, the cold crank.
It can lead to shedding of the material.
Exactly.
Yeah.
So the job of the expander is really to avoid that. And there's three components of materials that work together to do that. There's the lignosulfonate, an organic substance that's very well known, right? That comes from trees.
Different derivative from wood.
Exactly, and it's the lignin is basically harvested during the wood pulping process, and then through purification and oxidation and desulfonation, basically it is made battery grade, what we're using today. And what this material does is it leaches onto the lead, and therefore it helps to prevent the formation of those harmful passivating layers. And another interesting thing that it does, it does not only make the surface available for the discharge recharge reactions, but also about 20 to 50% of the negative active material volume. So that is a very important feature.
Okay.
Then we have a second material, is the barium sulfate.
Yes.
This is a different mechanism. It works on a different principle. Its molecule basically has the same length and molecular bonds, so it's very similar in structure as the lead sulfate itself. Okay. So what it does, it's basically a nucleation site for small lead sulfate. So you avoid large blanketing, but you have like very little small lead sulfate crystals, which means the negative active material is not passivated and blanketed, but it is more porous. Yeah. So it still maintains its function and surface.
And these are the essential additives.
These are the essential. The carbon,
is another essential additive.
Is the third one of those. Basically, adds a little bit of conductivity and has some other functions. So all these three together basically maintain.
They are the essential additives.
Yes.
Now, what about the performance enhancing additives? Can you throw some light on that?
Yes, for example, those are additives that are not only for the negative, that also go into the positive active material. One that is very common is the use of tetra-based seed crystals given to the positive.
Yeah.
And the idea there is that during curing at higher temperatures, you create nucleation sites through those seed crystals for the growth of large tetra-based seed crystals, which build a great substructure for the positive active material for deep cycle applications.
Yeah, but don't these also aid in the shedding then in that case, if you put a bit more than what is required? Or you're right. It needs to be dosed correctly. It's usually about 1% of weight of the oxide that you put in there. Yeah, and when you're using this, I think we got to be more careful about the dispersion, isn't it?
It is.
It is because if it is localized or something, then you have those plate shedding and you have problems, right?
And you don't want that.
You don't want that.
But that's actually more a problem that you have if you try to achieve tetra-based sulfate only through curing.
Yes.
Because that is never homogeneous. Actually, if you have those tetra-based seed crystal well dispersed, as you say, in the positive active material, it actually helps that you have smaller and better distributed tetra-base after curing.
But many a times people have tried using this and then they face problems, and probably is the reason because it has been not properly dispersed?
That might be one reason. Or some people just overshoot, right? They think the more I use, the better it is, right? And usually you should not have more than maybe 1% or so emission.
Okay. Now, what about the temperature? Is there any restriction when you're using a tetra-basic crystal?
Well, generally, so there's two methods really to create a tetra-based substructure, as I call it, right? So either you do it only through curing, then you have to go up to temperatures, as you know, higher than 70 70 degrees Celsius.
Yes.
The advantage of the tetrabase seed crystals is that you can actually use significantly lower, almost regular curing temperatures, around 45 degrees or below 50 degrees, and yet you will have a nice composition of tetrabase.
And what if you put the crystal additives, the tetrabasic, and also go above 70? Is it detrimental?
It is not detrimental, but it does not give you any additional benefit.
But you're sure it's not detrimental?
It is not detrimental, not in my experience.
Okay.
Maybe a couple of other functional additives, just to mention them real quickly. There is tin sulfate, for example, in the positive that's used for better cycle life. There is a mix of arsenic trioxide and antimony trioxide. And there's all kinds of things that help to increase the cycle life of batteries. And then, of course, there's additives that go into the electrolyte, like you would have sodium sulfate, right, to prevent harmful effects of deep discharge.
Deep discharge. Okay. Since these different chemicals have different functions, obviously a variation in the quantity of chemicals used depending on the applications is recommended, right?
That is,
So what is your opinion on this?
Yeah, I think that's a very important question, Ramesh. I think a lot of times people think, one solution fits all.
One size fits all.
One size fits all.
It doesn't.
Right? It doesn't, you're right.
Yeah.
And a very good example would be, let's look at the expander blend again, okay?
Yes.
So for automotive, the Hammond HE631 formulation. I think this is the widest spread in the world. I think by now everybody knows what 6, 3, and 1 stands for. You use about something 0.25%, 2.3% of lignosulfonate, right? And why that is because for an automotive application, that is in the maximum of its performance for cold cranking. So that's the ideal dosage for cold cranking.
Yeah.
However, think about now a motive power, a traction application.
Yes.
In traction application, you're not looking for cold crank, or you're not looking for very high currents per surface area, but what you want is good charge acceptance.
Yes.
But at that level that you use in automotive, 0.25 to 3, charge acceptance is relatively small. So you would actually, in a traction battery, use a different dosage. You would go to significantly lower lignosulfonate levels, because that way the charge acceptance comes up. With the barium content, it's the other way around. In automotive, you have around 0.4 to 0.6%, which you don't need in automotive. Standard automotive, you don't need very high cycle life.
Yes.
But in traction, you do.
Yes.
And the cycle life of the negative increases with increasing barium sulfate amounts. So here, other than in automotive, you would use significantly higher amounts of barium sulfate, probably greater 1%. Or so. So really, the exact dosage and how you design your expander depends very much on the application.
You say greater than 1%, but if you put too much of barium sulfate, it also can lead to shedding, right?
That is true.
So, can you define like greater than 1% or just a bit under 1%? Or greater means how much greater?
Yeah, I would always say you're in a safe spot if you're somewhere between 0.8 and 1.2%. I've seen that if you go beyond 1.4%, you actually do have you can see that the cycle life goes down again.
Yes.
And that is, as you correctly mentioned, mainly due to paste shedding.
Paste shedding.
That happens at that point.
So that's why I would always play safe and keep it like 0.8% rather than go on the other extreme. Again, in all these mixes, the dispersion is very important, of course. Needless to mention that. So, Mr. Achim, when you recommend these premix, are you doing so based on the chemical composition and your knowledge of chemistry, or based on the performance characteristics that you expect out of the product? Out of the battery, of course. Do you have validated results? And have you used the recommended mix formulations and got batteries made and tested the batteries before finalizing the various recipes?
This is a loaded question, Ramesh. So I try to kind of dissect it a little bit, like piece by piece. So first of all, There is a certain industry knowledge by now, right? There is certain standard formulations. Let's say for standard internal combustion engine, automotive, there are combinations that everybody knows and that without a shadow of a doubt, work.
Yes.
There is not much to be done, and I think almost everybody knows. In that case, we basically just provide the pre-mixing service, right?
Yes.
But when it comes to modern applications like automotive idle stop start or EFB, or when it comes to motive power opportunity rapid charge, right? Or when it comes to e-rickshaw or any type of partial state of charge operation or dynamic charge acceptance, then actually that's where the R&D starts.
Yes.
And what we have found, what I have found in my career is that, always using the most expensive material, the best lignosulfonate, the best carbon, and just putting them together really doesn't work.
Unless you put it in the right proportion.
In the right proportion, but also there is certain materials that have certain synergistic effects, or certain materials, even though they're sophisticated, they may cancel out each other. So that is something.
They can be detrimental, do you mean?
They can be detrimental, yeah. Because one of the things that you see is if you, for example, you have active carbons with a very high surface area. Sometimes then the lignosulfonate cannot discriminate whether it leaches onto the lead crystal, which is supposed to do, or actually onto the surface of the carbon. If it does so, it actually, you lose lignosulfonate to the carbon that should actually be sitting on the lead crystal, right? So in my career, since you asked, is it so there's some industry knowledge, but there's also research. In my career, I can say, and when you spoke, I was thinking about it. I think I tested about 100 different carbons in several hundred different material combinations. So I believe I have a pretty good idea of, for the various applications, which materials work together. And in our case, for Associated Electrochemicals and Moldcore, we did trials, particularly on the more sophisticated applications. We put materials together and we actually had them tested. Tested 2-volt cells and then also tested them in full batteries. So what we're having on the market, what we're offering now, is really something that we are convinced and sure that it does work.
When you say tested, have you just tested, or you've also done field trials and you have an experience of what the performance has been, not only with respect to capacity, but also with respect to life?
Yeah, we have a few. Well, life is always a little bit difficult, as you know, even in a field test, because those batteries will be out there very, very, very long, right? But we have worked with a couple of key customers that basically we sent almost like a beta site, right? Where we sent batteries to, and they have been testing, and they were performing within our expectation. If not, we had to go back to the drawing board and make a couple of changes. But that is R&D work, right?
Yeah, but as of now, the products you offer, they have gone through the R&D and they have been validated, and you're confident about the product.
We're very confident about it. I think we can, I think the thing that we believe makes us different than others is a lot of blenders, they read, some paper, that certain materials are good, then they just combine these materials and then they say, well, try this. I think
that's dangerous.
Yeah, I think in our case we really have a material scientific understanding of how the materials work together, and so I think we give really our customers, the best
value for money.
Yes, absolutely.
Okay. Do you also have an instruction manual on how the chemicals are to be used? I mean, the sequence of use, or whether to be used as a dry mix or to be added to the water and used, or whether something needs to be added to the acid, before the acid, after the acid, something like that. And have you ever considered doing a training program in this regard?
So I always say, I've been long enough on the battery side, right? On the customer side of additives, right? I have to say, I always like it cost effective and simple. for the battery maker. So, for example, I know there's people who offer slurries, for example, right?
I'm sorry?
A slurry, which is basically
slurry.
already you know,
Done.
the expander in a water tank or something. And I always found that this is an additional process step, you know, and it's inconvenient to the battery manufacturer. So I believe you sell a bag with the material, exactly the weight that you need for the specific paste batch that the battery manufacturer has. And then we give a recommendation, but there is a lot of sensitivity and different philosophies of the different battery manufacturers around the world on how exactly and when exactly they add what. My preference, personal preference, has been that you actually start with the oxide and the dry expander mix, and then later you add the water and then the acid in a last step. But other people, they do it differently. Some actually, they do their own.
When you say dry expander mix, you mean only the carbon and the barium sulfate? Or
Look, expander for me is always the 3 components, including the lignosulfonate. It all comes in one bag.
But lignosulfonate is mostly added with the water because it's too light, it flies a lot and makes the whole place dirty also, and you can lose a little bit of lignosulfonate because it's like a talcum powder.
I think actually the carbons, they're more airborne. And some of the modern carbons, they're even more fluffy, right? So they're the ones that
modern carbons, yes, but generally I've seen that people use barium sulfate and the carbon as a dry mix, and they put the lignosulfonate and the fiber in water and add it. I mean, what exactly is your recommendation as a person with a lot of experience in this field?
Yeah. So really,
can you be specific? I mean,
yeah, I can be very specific. And I give you a good example. So in the entire United States, right? People like it convenient, right? So that means they buy, for example, if you buy a Hammond product today, they always buy all 3 components together in the bag. It's always a homogenized mix of lignosulfonate, carbon, and barium sulfate. So, for example, you have a ton of oxide weight, 1%, for example, for automotive addition means 10 kilogram bags that you put in the mix. And that goes in the mix actually in the very beginning with the oxide. So you have the whole dry mix, then you add the water, then you add the acid. That's how most of them work.
So the sequence, according to you, is oxide, dry mix, put the chemicals in, dry, then the water, and then the acid.
Yes, that is, I think, the most used, for example, in the United States, of people that use premix expander.
Acha, what about the performance enhancing additives? When are they to be added? After the acid mix, before the acid mix, or before the water, or along with these chemicals?
I would if so expanders are specifically negative. You know, some of the performance enhancing would be for the positive active material, and I would go with the exact same sequence: dry first, then the water, then the acid.
Then the water and the acid. So the dry oxide, the performance enhancing additives for the positive, water, and the acid.
Exactly.
Okay. Do you mean to say there are no performance enhancing additives to be added to the negatives at all? Or do you have any performance enhancing additives for the negatives?
No, not outside of the realm of the expander mix, actually.
Okay. So the performance enhancing additives, whatever you sell, are for the positives and these are the negatives. Okay. Now when I'm talking of positives, I'm talking of pasted positives. In India, I have found certain people recommending some additives for the tubular positives. Do you feel this is required for the tubular positives? And in case it's required, do you have anything for the tubular positives?
Well, tubular positives, I always think, of course, of red lead.
Yeah, that's not
an additive.
It's not an additive.
Actually, the tubular.
Because I personally feel tubular positives don't need anything, but I've seen a lot of people campaigning, and a lot of people have used, and they've come back and they've had some problems also with the tubular positives. But I'm not sure whether it's due to the additives. And since you're an expert, I'm asking you: do you have anything for the tubular positives, or worldwide, or in your 30 years of experience,
no,
have you seen
no.
anybody adding something
No,
to the tubular positives?
I've not seen that, actually. I do not. And when I'm talking about, the stuff I mentioned earlier, the tin sulfates, the arsenic trioxide, the antimony trioxide, it always is the flat plate, the positive flat plate.
Yes.
Because that has difficulties in cycling, and of course by nature, if the active material is contained in the tubes, there is no problem, right?
No problem.
So I have really no recommendation, and I think you're right that it is not necessary for tubular positive.
Yes. So anyway, that's why I said I'm not sure whether these people added to the tubular positives and face problems. But wherever somebody has come to me, I've said, please don't add anything to the tubular positives. And somehow they've been also saying, yeah, the problem is not there. So I can't attribute it to the chemicals, but somehow we have got out with it. And I found that I personally feel there's nothing required for the tubular positives.
I 100% agree with you.
Okay, thank you. So now, one more thing I wanted to ask you is, a lot of people who are making batteries, I find quite a few of them, they go by what a person who is selling the chemicals says. He says you add so much, and they try and do that and something like that. So when I asked you about the training earlier, what I wanted to know is this training more required for the person who is selling the chemicals rather than the person who is going to use the chemicals? I'll give you my personal opinion later, but I want to understand from you.
Yeah. This is actually a good question. I think, thinking about it, I would say it's definitely more required for the person who sells.
Yes.
Because as you say, a lot of I'm always thinking about the small and medium type battery manufacturers that don't have a huge R&D department.
Yes.
They really rely on the material supplier to give them the recommendation for dosage and so on.
Yes.
So to have the salesperson, first of all, the salesperson needs to be understanding enough to ask intelligent questions, so they understand exactly the setup, the paste composition and everything that the battery manufacturer has, the application that he has, the problems that he may be facing, and then he needs to be able, based on that information, to recommend the right expander mix, the right formulation. So I would say training is very much needed for the salesperson.
Rather than
See,
what happens is people make these stationary solar batteries. The solar batteries means the batteries for the solar photovoltaic application. Now, in that particular battery, we say it's a stationary battery, and if somebody comes to sell, he says, "What are you making?" He'll say, "I'm making a stationary battery." Okay, it's a stationary battery,
but is it
it's
UPS?
not.
Is it telecom? Is it whatever?
The stationary battery for a UPS is different. A stationary battery used for a solar photovoltaic is different. A solar photovoltaic stationary battery is a bit cycled, though not to a deep depth of discharge of 100% or so, but still it's cycled. Another thing is the charge acceptance there has to be better because the sun is available for a shorter duration, unlike for a UPS battery which is connected to power. So all these things I think should be taken into consideration before the person recommending the chemical recommends the chemical for that user. So if he just says, I'm making a stationary battery, I think he should go and ask him, are you making it for a solar photovoltaic application or a UPS application?
In addition to that, I felt here in India, I learned, for example, if batteries go into rural applications where often the power goes out, right? So usually it's a big difference whether the battery is under constant voltage the entire time, or if the power is out several hours a day, right? So you're more in a partial state of charge application suddenly. And of course then, if the salesperson finds that out through intelligent questioning, he can then recommend an additive mix that caters to that specific situation. So you're right. It's on the sales side, definitely.
Yeah. Now, last, I want to ask you one thing. Do you think that a premix is better, or usage of the individual chemicals is a better option, a safer option? And what do you feel about it?
Okay, so first of all, generally, if you combine the right materials either way, if you do it individually, like most people in Europe do, right? That's a philosophy, right? They do this themselves. Or if you buy a bag that has the right materials and the right ratio, both will work, of course, right? Because chemically, it's the same thing. However, I believe that using premixed, has several very, I would say, distinct advantages, right? For the bed, always think about we want to make the life of the battery manufacturer easy, so he can concentrate on making batteries in the easiest way possible. So there's several things I'm thinking about as advantages. So first of all, the components are homogeneously blended to begin with, and they are quality control tested and they're packaged right in the right amount. The bags are sized basically exactly for the paste batch, the weight of the paste batch that the customer has. You can also, let's say, look at the expander, but you can also add, for example, the fiber that goes into the negative active material in the same bag. So it's a one-stop shop in terms of purchasing. You don't have to go chase the individual materials and all of that. You just buy from one hand and get the mix. So, and beyond that, I think the value is that you want to be, let's say you were looking at more sophisticated applications, as you and I have discussed earlier. As a battery manufacturer, you don't want to engage in material science. You do hundreds of different material tests. You leave this to us, people like us, right, who have the knowledge. We do that R&D for you, and basically you get something that is customized or tailored to your specific
requirement.
Need. Yeah. So that was what I'm saying. You do what you do best. In a simple way, we take a lot of the headache away from you, and you put the stuff in, and you have the right stuff, and it works for you, right? And we do what we do best, which is then the material science behind it, the purchasing of these material in large quantities, and so on.
Is there a possibility that some chemical has not been added by you, and the premix has reached me, and I wouldn't know because it's a totally mixed material? So why I'm asking you this question is, when you mentioned that Europe still follows the method of, I think the psychology or the tendency of the Indian public is more tuned towards the European methodology, and they feel that it's better to take the barium sulfate. I'm sure I've put so much barium sulfate, I've put so much carbon, I put so much of this, whereas the whole premix comes, I don't know how much carbon he has put. Maybe he had a shortage of carbon, he's put something less, put more of barium sulfate. Is there a possibility of such a thing happening?
Yeah, so I would say, I mean, this is really our bread and butter, right? This is at the core of what we're doing, right? And if we would sell mixes that, where the ratios are off or anything, in the end, it would come back to haunt us, right? So we're doing a lot of quality control to avoid that. I would be more concerned, actually, and we have this discussion with the European guys always, right? And I've seen, having worked in Europe, I've seen the problems that if you leave it to people, to, with a shovel or with some measure, with some type of a vessel to dose the material into the mix, I've seen a lot of miscounting, and a lot of mistakes there. So I think the danger
it's more the other way.
So I believe the danger of that is actually much greater than if we do this professionally, in our mixing operation.
Okay. Anyway, it was very nice talking to you, Mr. Achim. Thanks a lot for this enlightening session. And I hope we can discuss more on other topics in the future. And
anytime.
Thank you very much.
Yeah, thank you, Mr. Ramesh. Very intelligent, very, very good questions, and I really enjoyed our conversation. Thank you.
Thank you.
We hope the Q&A session was useful and insightful. You may contact us by writing to rameshnkailad@gmail.com, rameshnkailad@gmail.com. Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.